Welcome to the Harman Professional University AES67 Tools and Demonstration video. In another video, we reviewed the basics of AES67 and how it provides interoperability for other networked audio transports. In this video, we'll review some helpful tools that can be used for routing and troubleshooting AES67, and we'll finish with a live demonstration of establishing AES67 routes among a few devices. Autonate's Dante controller is necessary for interfacing with and configuring the Dante network interface card of devices such as the BSS Soundweb London Blue 806DA or Crown DCI-DA amplifiers. It is used for enabling AES67 output streams within a native Dante transmitter and is also used for setting AES67 subscriptions at receiving Dante devices. This does require that all AES67 streams must be present as transmitting devices across the top of the matrix. AES67 transmitters will be indicated by their blue font, while Dante transmitters will be displayed using a black font. In some instances, you may need to update the Dante firmware of a device. Autonate's Dante Firmware Update Manager is a standalone application that facilitates this. Dante firmware update files for HiQNet devices such as the BSS Soundweb London and Crown DCI Dante enabled devices can be found in the installation folder of Audio Architect. Depending upon your network configuration, you may need to connect your computer directly to the Dante primary network interface card of the device. Dante controller uses multicast DNS and DNS service discovery for discovery and enumeration of Dante devices. If using an IGMP configured switch, static routes must be established for the three streams at 224.0.0.230 through 232. This is necessary in order for Dante controller to be able to see detailed information regarding Dante devices. AES67 SDP is propagated via SAP on 239.255.255.255 port 9875. If using a BSS or Crown Dante enabled device, then Audio Architect must also be used for its device configuration. With respect to BSS DA devices and AES67, there are a couple areas that one should look out for. A device's Dante properties by default will be enabled for AES67, but it's recommended that this be verified. If a multicast prefix is required to be changed, then it will need to be accounted for here. By default, the prefix is 69, and this will be used in the second octet of the multicast address of the AES67 streams. Within the properties of a Dante block found within a BSS Blue Dante device, the routing type must be set to Dante controller. With respect to Crown DCI DA amplifiers in AES67, we can ensure that AES67 is enabled by taking the following steps. From the amplifier's master panel window, we can access the source routing panel. Then we may access either the input configuration or output configuration in order to gain access to the advanced settings where we will find the Dante and AES67 details. Similarly to the BSS DA devices, a Crown DCI DA amplifier can be used to transmit or receive AES67 streams. We need only to verify that AES67 is enabled either through the input configuration or output configuration. We don't need to check both. The multicast prefix is also available to be changed here. If a change is made while online with the device, then we can expect to see the reboot required LED become active. A reboot can be initiated through the amplifier's master panel tools menu options. The configuration of an AMX SVSI AES67 compatible device is a manual operation accessed at the device configuration through Enable or a browser. For a transmitter, we must manually designate the AES67 address and audio port. For a receiver, we will designate the AES67 audio address of the stream that it's subscribed to. The port and channels must exactly match the properties of the incoming stream as published in the SDP information. An AMX SVSI AES67 enabled receiver can support 2 or 8 channels. A couple other helpful tools that can be used for troubleshooting are Wireshark and RAV2 SAP. Wireshark can provide network troubleshooting and packet analysis, allowing for basic filtering of traffic and other protocols such as IGMP, SAP, and PTP. Ravina's RAV2 SAP application provides the ability to read the session description protocol information. Earlier, it was mentioned that at the AMX SVSI receiver end, we need to enter exactly the port number of the stream and how many channels are in that stream. Where do we find that info? We get that info from the SDP packet either using Wireshark or RAV2SAP if it hasn't already been documented. The SDP packet is the only place where we can absolutely verify the necessary information required by a receiving device to properly render the audio. With regards to AES67 deployment steps, let's take a look at the following. First, configure the network switches. Keep in mind that we will need to provide the static routes for Dante traffic. Second, configure and load BSS Audio Dante devices or Crown Dante devices through Audio Architect. Third, allocate and document AMX SVSI encoder AES67 multicast IP addresses. Fourth, we'll need to configure online SVSI encoders through Enable or using a browser. The fifth item is optional. We'll see that we can spoof SAP for offline AMX SVSI encoders using RAV2SAP. This is helpful if lacking physical AMX encoders. We can manually add in SDP packets for devices that do not exist, which will allow them to show up in Dante Controller. This then allows us to pre-configure the Dante interface without having the AES67 sources. Of course, for the next item, we'll want to configure Dante devices through Dante Controller. Next, through Dante Controller, we'll set up the AES67 routes for the Dante device inputs. AES67 streams must be present in order to route them to the receiving devices using Dante Controller. Then we can create AES67 multicast flows for Dante device outputs at Dante Controller. We have little control for manually specifying the multicast addresses coming out of Dante Controller. Where we do have the ability to designate multicast addresses, then this is recommended as in Step 3. Addresses manually designated and discovered in Dante Controller will not be duplicated when creating multicast flows for Dante device outputs, considering Dante Controller will randomly select multicast addresses. Finally, it's recommended that we document any Dante device's AES67 transmitter multicast IP address assignments. Let's work through an example of troubleshooting a faulty system. Today we are working with a Cisco SG300 10PP switch loaded with the following configuration file. Our AV hardware consists of an AMX SVSI 2412A encoder and a 2422A decoder, a BSS SoundWeb London Blue DA, and a Blue 50. The Blue DA will be used to receive any AES67 streams, which can then be Blue linked to the Blue 50 for any necessary audio processing. All device configurations have been loaded using each device's respective software application. In some instances, when using multiple IP addresses on a single network interface card, Dante Controller may not allow us to establish a connection. It is recommended that a single IP address be used. By default, Dante network interface cards are configured for DHCP. If they do not detect a DHCP server, then they will obtain a link local address in the 169.254.0.0/16 range. It should also be noted that if for some reason encoders do not populate Dante Controller, assuming they are physically connected to the network and powered on, then the most likely culprit is a firewall blocking multicast traffic. As noted before, AES67 SDP is propagated via SAP on 239.255.255.255, port 9875. Now with the Blue DA available, we can navigate to its device view to configure its AES67 options. We should find an AES67 tab, but it appears to be missing. As we look at the other available device info tabs, we find that many details appear to also be missing. So what does this tell us? Well, this must mean we are experiencing an issue with the static routes that are required to be manually configured. Let's access our switch and find the multicast group address options. BSS SoundWeb London Dante devices deliver this info on 224.0.0.231. So we'll pull up the details for this address and we'll enable the static route on the port our PC is connected to. Now we should find in Dante Controller that the missing details in the device view of the Blue DA are available. Let's verify that AES67 is enabled and the prefix is set to 69 as configured in Audio Architect. If we take a look at the Transmit tab, we'll see any available transmitting channels as they were configured in Audio Architect. A green loudspeaker icon will display if signal is currently present on a channel. Now, at this point, if we wanted to create a new AES67 stream to transmit from the blue DA to another AES67 compatible device like our decoder, we will need to create a new multicast flow and enable the AES67 option. Next, choose the channels that you want and click Create. A new multicast IP address will be generated, and we would want to document this in order to properly configure the AES67 information of our receiving device. For the last portion of our demonstration, let's look at spoofing an AES67 stream using the Ravina RAV2 SAP application. With the application open, we find that it's sniffing for SDP packets. Let's look at the details of one found in the blue DA. We can copy this info to use as a framework for creating a virtual spoof. The following elements will be required for creating the SDP packet: the V for SDP version, the O for session ID, the S for session name, the C for connection information, the T for time description, the M for media description, and one and only one A attribute with the RTP map information. We can select the local SDP option and paste in the relevant info. Let's provide a different source unicast IP to the session ID, a unique session name, and a unique multicast address to the connection info. Then we can remove any extraneous elements copied over from the original SDP info. Click OK, and then add the spoofed SDP packet to the SAP announcements by clicking on the plus sign under SAP. As we can see, this is an extremely beneficial way of pre-configuring AES67 transmissions for devices that allow us to specify their intended multicast IP addresses, as opposed to those that are automatically generated through Dante Controller. This concludes our AES67 tools review and demonstration. Thanks for watching.